when I have an intersection, how many angles do I have? 4, right? Okay? And I'm going to label them this way. Okay. So, why do I know that? Okay, and in this labeling drawing, blue is equal to blue. And red is equal to red. Okay? So, what allows me to say that 1 is equal to 4 and 2 is equal to 3? This is where we were going last week. Okay? And here's the quick and dirty proof of this. Okay? So angle 1 plus angle 2, what does that equal? Angle 1 and 2. 180. How do you know that? What? Yeah. Because right, a whole line is 180. All the way around the circle is 360. Okay? So, how about angle 2 and angle 4? Yeah, also equals 180, right? This time we're using a different line, but those two add up to be a line. Okay, so, who had the symmetric property that they went over? Made your video about the symmetric. What was the symmetric property?
I think it's the same.
What was it? What was the specific one? Thank you, Dylan, for getting the whole class attitude on this. Okay, symmetric property said if A equals B, then B equals A. Okay, so how can I use this? I want to change this guy with the symmetric property. What does that turn into? All right, let's say that this is my A, and this is my B. Yeah, 180 equals angle 2 plus angle 4. Right? If the left equals the right, then the right equals the left. Okay? So that was the symmetric property. And I'm going to just get rid of this guy for now. Okay? So, who had the transitive property? This said if, with the transitive property. Be quiet. Take your notes. All right. Transitive property said if A equals B and B equals C, then what? A equals C. Okay, so how can I apply that to the situation I have here? Well, let's take a look. What if this is my A, and that's equal to my B? All right? And then look, I have a B here as well, and that's equal to something different, my C. So what does the final statement say? Angle 1 plus angle 2, that's my A. What's my C? Yeah. Right? It's not rocket science here, right? Angle 1 plus angle 2, that's a straight line. That's going to also equal angle 2 plus angle 4, another straight line, right? Okay, how do we simplify this? This thing's a little bit busier than it needs to be. What's on both sides of this thing? Angle 2. So let's get rid of it. Yeah, we're going to minus an angle 2. Okay? An angle 2 minus an angle 2, that goes to a 0. This also goes to a 0. Now I just have angle 4 is equal to angle 1. Right? Ta-da! That's what I was trying to show. And we call these vertical angles. And does anybody remember Lena Littleplume? I'd never seen this before, but she came up with this way of remembering it that I really like. I thought that was really smart. Right? Vertical angles. It's pretty cool, huh? Yeah, I think so. So, can you guys come up with an argument for why 2 is equal to 3? Yeah, probably, right? You just have angle 2 plus 4, that's equal to angle 3 plus 4. And then I'd subtract 4 off of it, right? Alright, so there we go. So that gets one thing, but let's say we want to expand. Right? Let's add a third line into the mix. Okay, so here's a question for you. Parallel lines, right? We have these little symbols, little arrows on the lines to denote they're parallel. Okay? What do parallel lines never do? Cross. They never intersect, right? So, if they were to intersect, let's say somewhere over here, what would I have over here? What's a figure that has 3 intersections and 3 sides? Triangle, right? And then all the angles in a triangle, they add up to 180. Okay, I know I'm hitting the ground running after Christmas break, but I'm sorry, that's what we got to do today. So, if these angles all add up to 180, right, then this angle down here, which I'm going to call angle 5, or it's going to be 6, 4 and 6, right, they would have to be less than 180, right, if they intersect, right? What happens if these two angles are more than 180? They won't intersect, but they will over here, won't they? Right? Let's take a look. If I have this, and I have these angles, right? Those angles are going to add up to be more than 180. They're going to intersect over here, right? If they add up to be less than 180, they're going to intersect over there, right? So we need these things to add up to be exactly 180, okay? And similarly, you guys do this. Blue plus red equals 180. So that's the rest of my color scheme up here. Okay, so how many angles do I have here? How many angles do I have? Total up here. 8, right?
What's up, dude?
But how many different angles do I have up here?
4. 2.
2. Right? All of the reds are equal to each other, and all of the blues are equal to each other. And that's the big thing here. Now, what's going to be the difficulty is not getting these in your head, but generally the labeling of this is the hard piece. So, here's how this is how it is. We need to go over all of the vocab associated with this, which this unit's kind of heavily vocab heavy. Yeah. And the ACT will test you strictly on this vocab. Okay? So this line here is called the transversal. Okay. That word trans, it's got a specific meaning. Like, what does transcontinental mean? Transcontinental. We live on a transcontinental railroad. What does this railroad do? It goes across the continent, right?
So cross.
Yeah. Trans basically means to cross or to switch over, right? To transfer. To transport. These all have the ideas of moving across. Like if you transfer money from one bank account to another bank account. That is one too. But you could transfer the ball from your right hand to your left hand, dribbling. And that's a crossover. Crossover is a transfer. So, now there's 2 types of paint, right?
Wet paint or dry paint?
No. Okay. There's paint that you paint your outside of your house with, and paint that you paint your inside of your house with. What are those called? It's a fancy word for in and out, basically. Interior, and what's the opposite?
Exterior.
Exterior. Just exterior. Exit practically means out, so exterior.
Okay. Here we go. So there we go. Okay. So the labeling of this is made up of this way. You need to be taking notes.
I like weird.
Just let me get through this and then you can ask. Okay? Okay, how about this word? Alternate. Can you think of something that alternates? Girls, hands to yourself. Okay. And what does the alternator do?
I don't know.
Who knows what an alternator does?
Something to start your vehicle. I just know where it's at.
Your alternator kind of charges your battery.
Yeah, that's what I meant. Like starts.
No.
Charges, stores.
Yeah. How about this? If you guys are in line at the DMV and you're trying to get your driver's license, and there's one cashier and 2 lines, what is the polite societal norm thing to do?
In one line.
You have a person from line A go and a person from line B. Who goes next? Line A. And then after that? Line B. And then after that? Yeah, line A. It's like what a zipper does, right? 1 tooth from one side, 1 tooth from the other, 1 tooth from this side, that side, this side, that side. And then eventually you have this nice cohesive thing. Okay? The way we use this maybe is a little weird, but we're going to say that 5 and 4 are on alternate sides of the transversal. They're on opposite sides of the transversal. You can either be on the same side or alternate. Okay, so let's take a look. This is how a bunch of these are named. So we have same side interior angles. Can anybody tell me give me 2 angles that are on the same side of the transversal and interiors?
Square.
Are those angles?
Oh, I don't know what you're talking about. That's not. 80.
Ooh, okay. Same side of the transversal. All of these are going to be 1 angle from the top intersection and 1 angle from the bottom. So 4 and 6, right? They're on the same side of the transversal and they are interior. Now, what other angle is interior?
3 and 5.
3 and 5. Okay, so do 4 and 6, do they equal each other or do they add up to 180?
Add up to 180.
There you go. So same side interior angles add up to 180. Alright? Okay, let's look at same side exterior now. What are 2 angles that are same side exterior?
1 and 7.
1 and 7. Take some notes. Am I done?
2 and 8.
2 and 8. I understand it's the end of the day, guys, but we need to get through all of this. You guys can go to the bathroom. After that, we can move on, but the longer this takes, the longer that'll be. Not now.
My block is like pushing.
You're a grown up, man. Almost. You should be able to have some bladder control.
Oh my god.
Okay, somebody other than Jace. Do these add up to 180 or do they equal each other?
They add up to 180.
Thank you, somebody other than Jace.
She said yeah.
Yeah? Alright. Alternate interior angles.
They equal each other.
But which angles are alternate interior?
One in, or for the interior,
Interior.
they'd be 4 and 5.
Jace, would you get that? Alright.
Who is
it?
Who is this? Oh, attendance office.
Alright. Can I ask him if I can call back in 5 minutes?
Can you call back in 5 minutes? Okay. Shawana Gray is being checked out.
There you go. Alright, so which is alternate interior? 3 and 6,
4 and 5.
and 4 and 5. Okay, so in my scenario, I've labeled them this way. But for all I care, we could have started with 1 and ended with 8. Okay? So, alternate exterior.
2 and 7.
2 and 7.
1 and 8.
1 and 8. Alright, so that doesn't count all of the angles, does it?
Wait, why'd you write them twice? You got them on the side.
What do you mean?
You wrote alternate exterior, but you got it on the top. Like alternate.
Alternate
Right to
interior.
the top dot.
Alternate.
Yeah, and you rotate again.
Okay, see how this is a grid, right? The top column of the grid is all interior, right? The bottom column of the grid, or the bottom row, is all exterior.
Yeah, see
The right column is all alternate. This one's all same side.
Oh, why'd you write them again?
It's a
I
table.
just wanted to know, Miller.
It's a table. It's a good labeling convention.
Alright, thanks.
Okay, these are all equal. These are all equal, right? Okay, what about angles 6 and 2? What do you know about those two angles? They're the same. Okay, this one we have this word corresponding.
Corresponding.
Okay, and if this is north, south, east, and west, can you guys think of another circle and where would east correspond to on that circle? There's another circle that has labels all around it.
Clock.
Okay, and what does east correspond to?
3.
3. Right? That's where this word corresponding means. It doesn't mean that you and me are going to send letters together, or that 2 and 6 are sending letters to each other. Right? It's not like a correspondence between people. Okay, this idea of corresponding might just mean that we're in the same, or in this case, it does mean that we're in the same space relative to something. And here, what we're relative is to this intersection. 2 is in the upper right-hand corner of this intersection. 6 is in the upper right-hand corner of this intersection. So they're corresponding, right? Similar to how north, south, east, and west, this is going to be a 3. This is going to be a 6, a 9, and a 12. So that's where that word comes from. So what are all of my corresponding angles? I already gave you 1, 2, and 6. What's the other red one?
1 and 5. Oh,
1 and 5 is another corresponding.
3 and 7.
3 and 7.
4 and 8.
And 4 and 8. So what do you know about corresponding angles?
They're equal.
They're all equal. Okay. That's going to be the theme of this whole unit. Is are they equal or do they add up to 180? And all problems are going to be set up that way. Okay? They either add up to 180 or we set them equal to each other. And really, that's about it. Okay. So, at this point, I'd like to give you guys the assignment. You probably can stop video.